In this video, we're going to discuss the least square regression line. This is the line in which we can use to make predictions on association. We also use it to identify whether something is close to being correlation or not. What it does is it takes the sum of the squared distances from the horizontal values, or actually the vertical values from the line, so from the y values, and it finds where they're the smallest as possible. And so what we're trying to do is make those values, the difference between the value and the line, as small as possible. And when doing so, we use the standard deviation or the mean as well as the correlation coefficient to help us solve this for this equation. What this equation looks like is it looks like y hat is equal to b sub 0 plus b sub 1 times x. If we were to reorder this a little bit, it would look like our y is equal to mx plus b, our slope-intercept form. And so b1 actually represents our slope, whereas b sub 0 represents our y-intercept. Y hat is what we use to make predictions. So this y hat is our predicted value that we use. And that is why it's not just y, it's y hat, because it's a predicted value. Now we have to be able to solve for our slope and our y-intercept because those are not usually just given to us or anything. So we have to be able to calculate those. So for our b sub 1, our slope, we calculate it by using the r, the correlation coefficient, times the standard deviation of our y's divided by the standard deviation of our x's. And the reason why it's y divided by x is because remember that slope is rise over run, which is the change in the y's over the change in the x's. And so we still keep it the y's over the x's. And again, remember that this represents the slope. Meaning, as x changes, how much does our y change? Now our y-intercept is calculated by the mean of the y's minus our slope times the mean of our x's. And so this is our y-intercept. When we're looking at these, we obviously have two different variables because we're talking about the x variable and the y variable. Well, the x variable is usually called the explanatory variable, meaning it is used to explain the other one. So it's used to explain or predict the value of the other variable, which is our y variable, which is usually considered the outcome variable. So x is used to explain or predict the value of our y variable, especially if you notice in this equation right here, we substitute in x so we can predict our y value. So let's look at an example of how to calculate our least squares regression. So we're looking back at the same problem earlier where we had the golf pro that wants to investigate the relation between the club head speed of a golf club measured in miles per hour and distance in yards that a ball will travel. We want to compute the least squares regression for predicting distance from the club head speed. Recall that the mean club head speed is 101.88 and the standard deviation is 2 and 295 thousandths. The mean distance is 266 7/75, with a standard deviation of 7 741 thousandths. And so we need to look at first, when we're doing this, we need to find B1, which is R times SY over SX, and B sub 0, which is our mean of our Y minus our mean of our X times our B1. And so we've actually got to make sure that we calculate our slope first. Well, in order to calculate our slope, we've got to calculate our correlation coefficient. And so going back to our correlation coefficient, I don't want to use the rounded version if at all possible. So I'm going to go back to where we had 6.57169 divided by 7. And then my standard deviations, 7.741 divided by 2.295. And so I'm going to do this division and multiply it by this. And so my slope is 3.167 when I do that calculation, and I'm going to round to about 3 decimal places. Now I can use this value to find my y-intercept over here, because my y-intercept is my mean of my y's, which is 266.75, minus the mean of my x's times my slope, 3.167. So that means that I've got 266.75 minus 322.65396. So this is going to give me a negative 55.904 as my y-intercept. So my line is going to look like y hat is equal to negative 55.904 plus 3.167 times x. Now I would be able to use this line to predict any other value of my distance for my ball if I knew the club head speed. A couple of things regarding my slope and my y-intercept. My y-intercept is where it crosses the y-axis. And so we look at this and we say, okay, well, that's all well and good, but whenever I remember that that's whenever x is 0. Well, I don't have any x's even close to 0. So my y-intercept actually does not mean much to us unless our data contains both positive and negative numbers. So there's not much of an interpretation that we can use whenever our data only contains negative numbers or only contains positive numbers. Now our slope, yes, that is valuable to us, because what this says is that for every value of x, or the club head speed, the distance is going to increase by 3.167. That's exactly what this is referring to in this particular case. So for every mile per hour of the club head speed increase, the distance is going to increase because it's positive slope. Let's look at another example. And this says, do larger butterflies live longer? The wingspan in millimeters and the lifespan in the adult state in days were measured for 22 species of butterfly. The least squares regression line for predicting the lifespan for the wingspan is, and that's going to be y hat is equal to 52.0434 minus 0.8445x. Predict the lifespan for a butterfly whose wingspan is 28.5 millimeters. Well, since we're wanting to predict the wingspan, our y value, what we're going to do is we're going to plug this 28.5 in for our x. And so we're going to have y hat is equal to 52.0434 minus 0.8445 times my 28.5. And so I get that y hat is equal to 52.0434 minus 24.06825. So y hat is equal to 27.98. So that means a butterfly whose wingspan is 28.5 millimeters has a predicted lifespan of about 27.98 days. Notice I rounded to 2 decimal places. Usually we round to 1 place more than whatever our value we inserted is. And the reason for that is because we've done some extra calculations, so we don't want to necessarily round to that exact same decimal place. We always want to go 1 place more than that. So I went to 27.98. And so, again, a butterfly whose wingspan is 28.5 millimeters has an expected lifespan of 27.98 days. So what I want you to do is make sure that you try to calculate the least squares regression line using the slope, the y-intercept. You need to be able to calculate those. And then also try to make some predictions based on a least squares regression line. And let me know if you have any questions.